All right, so as we move on to assignment number 6, we're going to be using what we've done in the first 5 assignments in order to find lengths of sides in a triangle using the Pythagorean theorem. So you may have studied the Pythagorean theorem in the past, but that's what our topic is today. It also involves simplifying radicals, and so we're going to be combining a lot of the things that we've done in the first 5 assignments in this assignment. So let's go ahead and get started. The Pythagorean theorem is a relationship between the two legs of a right triangle and the hypotenuse of the right triangle. So the legs of the right triangle make up the right angle. And so both of these are considered the legs of the triangle. A lot of people think that the hypotenuse is a used toilet on an airplane, but really the hypotenuse is the side opposite the right angle. That was a joke, by the way. A lot of people, the hypotenuse is really the side opposite the right angle. And so the relationship is this, that if we call one leg A and the other leg B, and the hypotenuse we call C, the Pythagorean theorem says that A squared plus B squared equals C squared. And so we're going to use that relationship to find sides of triangles. Here's how this might work. So if I have a right triangle, here's the right angle, where one leg is 4 and one leg is 8. The hypotenuse here is x. I can figure out the length of x by taking a squared plus b squared equals c squared. A squared, well, I'm going to let that be 4. That's 4 squared. That equals b squared, which it's plus here. So plus b squared, that's 8 squared. And that equals c, which in this case, that's the hypotenuse. That's x squared. And so we have 4 squared is 16, plus 8 squared is 64, and that equals x squared. But 16 plus 64 is 80, and so x squared is equal to 80. Well, we want to figure out what x is, so here's where the radicals come in. We're going to take the square root of both sides, and that means that I'm going to have that x equals the square root of 80. Now there's 2 ways that I can write the square root of 80. And really, before I find the square root of 80, I could estimate with the square root of 80. I know it's going to be between 8 and 9 because the square root of 64 is 8 and the square root of 81 is 9, and the square root of 80 is right between those two. If I take the square root of 80 on my calculator, I'm going to get something really close to 8.9. But it's not exactly 8.9. It's like 8.9. The decimal keeps going on and on because it's an irrational number. So it's close to the square or to 8.9, but it's not exactly 8.9. If I want to leave it as an exact answer, I'd have to take the square root of 80 and simplify it. Well, to do that, I'm going to figure out what goes into 80. The biggest factor, the biggest perfect square that goes into 80 is 16. We know that 16 times 5 is 80. And so the square root of 16 is 4, radical 5. So if I wanted to leave it as an exact answer, or sometimes what we call simplest radical form, I would have to take the square root of 80 and write it as 4 radical 5. And so if I could round the answer to 8.9, but if I wanted to write it as an exact answer, I'd have to simplify the radical and write it in simplified radical form, which would be simplest radical form, which would be 4 radical 5. So we can write the answer 2 different ways. Let's go ahead and talk about why this works. If I have a triangle, so this triangle has an A, B, and a C side. Here's my right triangle. But if I add the same triangle to it 4 different times and label the sides of the triangle the same way that it is here, then the shortest side is B. So here's a B, here's a B, and here's a B. The longest leg is A. So here's an A, and here's an A, and here's an A. And the hypotenuse of all of the triangles is C. So here's a C, and here's a C, and here's a C. Well, suppose that I want to find the area of the shaded region. Well, there's 2 ways that I could do that. I could maybe I can do just the area of the inside triangle, this rectangle in here, which is the c squared. If I want to find the area of this inside square, one thing that I could do is take the area of the outside. If I take the area of the big square first, I'm going to have to multiply its length times its width. Well, that's going to be a plus b times a plus b. And then I'm going to subtract the area of the 4 triangles. So I have 4 triangles, but to find the area of one of the triangles, I'm going to take 1/2 times its base, which is b, times its height, which is a. And so I would have to simplify that from both sides. So I'm going to go ahead and simplify this so that I can get an expression for the area of this inside square. So I'm going to FOIL first. I'm going to take a times a is a squared. And then a times b is ab, so plus ab. Then I'm going to distribute the b out. B times a is another ab. And then b times b is b squared. But then I'm going to subtract the area of the triangle, which is 4 times 1/2. Well, 4 times 1/2 is 2. And then b times a, I'm going to write it as a times b. So let me combine like terms. I have an a squared here. I have ab plus another ab minus 2ab. So ab plus ab is 2ab minus 2ab. All of those cancel out. And it's a squared plus b squared. That's an expression for the area of this square. But that's not the only way I can find the area of the square. I know that the side of the square is just c. So that means I can find the area of this square by taking the length times the width. So the area, another way to write the area is to say it's c times c, which is c squared. So that means that a squared plus b squared, that's one expression for the area of the inside square. C squared is another expression for the area of the inside square. That means that these two things must be equal to each other. So that's a proof of the Pythagorean theorem. Let's go ahead and take a look at some more examples about how it works. So our classroom, this is true by the way, is 40 feet long by 30 feet wide. So it is 30 feet across, 40 feet in length. It says, what is the length of the diagonal? We want to find this distance, the diagonal distance of our room. Now we could measure it, but if we know that it's 30 by 40, we could find that distance by using the Pythagorean theorem. We would start with a squared plus b squared equals c squared. And the a and the b are interchangeable, but they're the two legs. So the two legs are 30. So we're going to have 30 squared plus 40 squared. And that's going to equal the diagonal distance. I'm going to call that c. That's the hypotenuse, c squared. So 30 squared, 30 times 30 is 900. Plus 40 squared is 1,600. That equals c squared. And so 900 plus 1,600, that's 2,500, equals c squared. So then I want to figure out what just c is, so I'm going to take the square root of both sides. If I take the square root of c squared, I will get c. The square root of 2,500, well, we could think of it like this. That's 25 times 100. And the square root of 25 is 5, and the square root of 100 is 10. So we're going to have 5 on the outside, a 10 on the outside, and 5 times 10 is 50. That means that c has to be 50. And if I were to take the square root of 25, I would get exactly 50. So the distance, the diagonal distance of our classroom would be 50 feet. Let's take a look at another one. A 70-inch television means that the diagonal of the screen is 70 inches. So if you have a television set and it's a 70-inch television, that means that this distance here is 70 inches. Suppose that the distance of the TV is 40, the height of the TV is 40 inches high. We would want to know what's its length. What's this distance? How wide is it? And so here we have a right triangle. the a and the b are the x and the 40. If I start with a squared plus b squared equals c squared in this example, what I know, let's say the a is x, that's going to be x squared, plus the b, I'm going to call this distance, this leg b, that's 40 squared. That equals the hypotenuse. Now in this case, the hypotenuse, we know it's 70 squared. So this is a little bit different because my unknown is on the left-hand side of my equation. So let's go ahead and see if we can work through this and solve this. We have x squared plus 40 squared is 1,600, and 70 squared is 4,900. And so then I want to get the x squared by itself. I'm going to subtract 1,600 from both sides. So 4,900 minus 1,600 is 3,300. But then I want to take the square root of both sides. So if I take the square root of x, I get x. The square root of 3,300, again, can be written in two different ways. If I want to write it as an exact answer, I'd probably make it the square root of 33 times the square root of 100. And the reason I did that is because I know the square root of 100 is 10. So I could write it as 10 radical 33. That would be an exact answer. But if I want to figure out what this is as a decimal, I would just take the square root of 3,300 on my calculator, which is 57.45. And so it would be 57.4 feet wide. Not feet, inches wide. And so that's how I can figure out the diagonal, the length of the television set. Let's do one more question here. We want to find the perimeter of this triangle. Remember, the perimeter is the sum of all the sides. I know that one side is 5, one side is 10. So I'm going to take 5 plus 10 plus I have one more side that I don't know. That's the hypotenuse. So I need to find the hypotenuse here. So if I use the Pythagorean theorem, let's call the hypotenuse x. I'm going to have one leg, which is 10 squared, plus the other leg, which is 5 squared. That's going to equal the hypotenuse, which is x squared. Well, 10 squared is 100. 5 squared is 25. That equals x squared. So 100 plus 25 is 125 equals x squared. If I take the square root of both sides, I'll have that x is 11.2 if I round it. So if I add this side is 11.2. If I take 11.2 and add it to the 10 and the 15, I'm going to have 26.2 centimeters for my perimeter. So the other way that I could have written this is the square root of 125 can be written as the square root of 25 times 5, which is 5 radical 5. So if I were to stick that here, I would have 5 plus 10 is 15 plus 5 radical 5, and I would have to leave it like that. That's what the exact perimeter of that triangle is. And of course, this is assuming that it's a right triangle. The Pythagorean theorem only works in right triangles. So that's what we're going to be working on in our homework today. And we will go over questions that you have on that tomorrow in class.